So bridge port extensions. So basically we need large switches, and Cisco came up with this idea that we could have lot of ports and they don't have to be all in the same box. Ports could be outside the box, but the control and management will be in one box. So they came up with the concept of fabric extender. Fabric extender is an empty box with a connector in it, with some intelligence but not too much. Okay, so all the intelligence, actually most of the intelligence comes from the parent switch. So parent switch tells it, this is how you basically, it immediately clears what it tells, but basically it will simply say that make 2 copies of this packet and send it to 2 people. That's the kind of thing that will say, not too much more. So you have fabric extenders which have ports in it, and then you have the parent switch which controls those ports, remotely controlled ports. And so the whole thing looks like one switch with many ports. So beside the number here, if you have 48 port extenders and you have 16 of them, so you will have a 576 port switch. Okay, and good thing is that there is only one thing to control, so you don't have to worry about whether this how to control that part. You don't have to control 16 switches, you just control one switch. Actually, you don't control 17 switches, you just control one switch. And so you could have 2 parents, which is not shown here. So this extender could be connected here as well as to another switch. So there will be 2 parents. If this parent goes down, you continue to work with the other parent. So that is not shown, but you could have 2 parents. And the way it is done in the data centers is that you will have extenders in the rack. Each rack will have extenders, actually 2 extenders, just to be fault tolerant. And these extenders will be connected to the switches which are in the end of the rack. Alright, so this whole thing is one switch. This whole thing is another switch. Make sense? So the fabric extenders are very simple boxes just with simple ports in it, and the brain is here. So this whole thing acts like one switch. And if you use virtual port channels, VPC, port channels, VPC, that's a very common word in the industry, so you should remember that now. VPC, virtual port channels, then all the links can be active because this is the configuration. You have a server, each server is connected to FEX, and each FEX is connected to 2 switches, and so on and so forth. Now, if you do virtual port channels, these 2 will look like one. Right? So everything will be active. Yeah.
So is this how is this different from the end of row topology?
Previous topology?
Yeah.
Yes. The thing is, this is different in the sense that these FEX are very cheap. Okay. So in the previous case, you would have a real switches here.
I mean, end of row.
Or end of row, you will have to take lots of wires.
But
Here you are not taking wires. You are just taking the wire from the FEX. So the FEX has maybe 16 wires coming to that, but only 1 or 2 going out. So this is still top of rack in terms of wiring. See, the disadvantage of end of rack was too much wiring. So this doesn't have too much wiring.
But if the wires group together?
No, they are not going together. One wire can bring all 16 ports. Okay, let me show it again. Here it looks like the number of wires is equal to the number of ports because there are 4 wires and 4 ports. That is not the case. Only one wire is required for 16 ports. I have shown 4 here because you may want 40 gigabit. You don't want 10 gigabit each, right? So this is just over provisioning. We have just put 4 where only one is required. Right? And so you might have 16 ports here, but only one wire total here. You could have 2 wires if you needed more capacity. If you 3 wires, 4 wires, 5 wires. But if you put 16 wires, I think then you really didn't get any benefit. Right? So the number of wires is small compared to the number of ports. Okay? Alright, so here you see these wires are coming up, and then only one wire goes to this switch and one wire goes to that switch. So 2 wires going out. Now you could double that, and so on and so forth. As much capacity you need, you could put. But basically the number of wires is still, smaller. Alright, so this was standardized by IEEE. And it is called Virtual Bridge Port Extension, VBE. Now there is no P there. Virtual Bridge Port Extension. And this is a very new standard, 802.1 BR 2012, with a capital B with a capital R, means it is a standard by itself. And it does exactly what we said before, is that you have a controlling bridge, you have extenders, and you can have a cascade of extenders. So you could have an extender, another extender, and so on and so forth. Some of these extenders could be inside a host. See, this is one host. So this is a vSwitch. So the vSwitches could act as an extender. The advantage of this approach is now you don't have to worry about VEB or VEPA, because these ports are completely controlled by this. They are following all the policies. Okay? So you can see all the traffic, you can follow all the policies here. So these bridge port extenders could be real or virtual. It could be a physical box, or it could be just a vSwitch. So now this combines both the DVS concept. You remember the DVS concept? Distributed Virtual Switch from VMware, where everything was vSwitch here. That will be covered by the same standard. You could take lots of vSwitches and make one big switch out of it. That was the VMware concept, is now bridge port extension. Or you could take lots of physical ports like Cisco concept and make a bridge out of it. Both of them are covered here, and these could be cascaded. Any question about this? Now this standard is a big standard, and believe it or not, there is not much public documentation about this. It just came out, so I read the standard and I prepared 10 slides, just put one here, 9 are in the background. But this is where you need to go and read. If you need to know more about it, you need to go and read the standard itself. And I didn't want you to read the standard. This is probably too much for this class. But if in real life, if you are to implement this thing, you will have to go and read the real standard. Okay? If there are no questions, then we are end of this chapter at this module. 5 key points: that network virtualization includes virtualization of many things, including starting with the NICs, bridges, routers, L2 networks, and so on and so forth. And in this module, we have just covered only one part. In the original picture, if you remember, there was a table we said in the beginning of this module. There was a table which said, how do you virtualize? So we haven't gotten to L3 and both those other things, right? But this is just some parts. And we talked about two kinds of virtual switches, vSwitches, VEB and VEPA. VEB is local loop, and VEPA is external loop. This is internal, this is external. Then we looked at SR-IOV, which was the PCI stuff. In the PCI, you could have one NIC provide multiple virtual NICs. So you don't have to worry about hypervisor doing it or having CPU work on these codes. Okay, it is done by the NIC itself. Then we went through VSS today, or last time, which allows multiple switches to appear as one logical switch, and VPortChannel, which allows links to appear as one. Multiple switches links to appear as one. So virtual port channels. Okay, good. Fabric extension and virtual. Then last thing we discussed was fabric extension, which is the same, which is actually a proprietary technology. The standard is called virtual bridge port extension. Now I missed the word port here, but it is virtual bridge port extension, and that is VBE. All right. And then basically you can create large switches. Now reading list. Some of these white papers are easier reading than the book. That's why they are ordered like this. And these are PowerPoint presentations. Some of these are PowerPoint presentations that also provide more details. But so that is that for SR-IOV. Another thing is IBM Red Books. I don't know how many are familiar with IBM Red Books, but IBM Red Books are really good because they're free and they're 400-page books. Okay, and they're really thick books, but they're free online, so you can just download them. It's a 654-page book, and I find them they're very well written in some sense. I mean, obviously they're vendor books, so they go a lot, and with their product you have to just read it out of it, but they're on good topics. So that is, then there is anyway, and then there is an excellent presentation in SNIA. This is a PowerPoint PCI. So I wanted to read that. And anyway, so, and there is some information on the Wikipedia. So here is the thing. I think, let me finish this. Any question about this? Okay. So I'm going to stop here.